Today we're going over solving equations by graphing. And so just as a prerequisite skill that we need to do this, let's talk about actually graphing this line over here. It is in y equals mx plus b. So remember the b value, the -4, that is your y-intercept. So you go down to -4 right here. And then the slope is 3/2. And remember that's rise over run. So it tells you to go up 3 over 2. And then do it one more time, up 3 over 2. And then you're going to use preferably a ruler or a straight edge of some kind to draw this in. The straighter you draw the lines, the more accurate they are. So I'm going to use this little tool real quick to get my straight line. But yes, it would be definitely important to go ahead and use even just like the side of your ID to get a nice straight line. Okay, so when you have an equation equal to another equation, those are two separate equations. You can write them as y equals the left side and y equals the right side. They're two separate equations. So what you're going to do is you're going to graph the functions, the x value of an intersection point of the graphs of the functions is the solution of the equation. So it's only the x values for the solution. I'll show you why on this example. So you have the left side of an equation equals the right side. You can rewrite the left side as y equals -x plus 1. Rewrite the right side as y equals 2x minus 5. And you can go ahead and graph both of these. So the first graph is -x plus 1, so it has a y-intercept of 1 and a slope of -1. Think of that as -1 over 1. So the rise is -1, that means it goes down 1, and then to the right 1. So down 1, right 1. All right. And when I do it on the computer, put more points than is necessary by far, just so I can get my line drawn in accurately. So let me draw my line in real quick. Okay, so here's my line, and that's for the left side of the equation. And then you do the same thing for the right side. So the y-intercept is -5, and then the slope is 2. So think of that as 2 over 1. Remember, it's rise over run. So up 2 over 1. Up 2 over 1. Okay, so now I'm just going to draw my line in real quick. And so graphing the left side and the right side as two separate lines is just a different way to solve this. I know we could solve it fairly easy algebraically, but this concept we're going to extend to other things. That's why we're going over it. So where it intersects is right here. This intersection is at 2, -1, and we only use the x value. And the reason you only use the x value on these is look at the original equation right here. It was just x's. We added in the y to graph it, but if you look at that equation I highlighted, it was only x's, so x equals 2 is our solution. Okay, so on this one, you're going to go ahead and you're just going to do the left side is y equals half x minus 3, and the right side is y equals 2x. So you graph them as separate lines, so -3, and then our slope is 1/2, so up 1 over 2. All right, I'm going to stop and draw a line real quick. And try to make your line extend across the graph. You don't just want a small line that doesn't take it up. Go ahead and make it extend all the way across. As we get closer and closer to section 5-7, we're going to need that. So let's get in that habit now. And then y equals 2x. It does not have a y-intercept. So the y-intercept's 0 is what that tells us. And then up 2 over 1. The slope is 2. So that's rise over run. And then let's draw that line in. All right. Get that straightened up here. Okay, so we've got that line drawn in, and then we look at where they intersect. And they intersect at the point, let's see, that's -2, -4. But look at this equation. We only want the x value, so x equals -2. Okay, solving an absolute value equation by graphing. We graphed absolute value equations, so you just take the left side and write it as y equals the absolute value of x plus 1. So remember that what that is, that means it moves left 1. So the vertex is no longer at 0, 0. It moved left 1. And then the sides are still up 1 over 1, up 1 over 1. Remember, an absolute value is that V-shaped. We did this in chapter 1. So there is my absolute value for that first graph. And then the right side is y equals absolute value of 2x minus 4. Now, because of that horizontal stretch, this one's a little harder to graph. So I just went ahead and I made a table. So I used my calculator. I plugged in 0, 1, 2, 3, and 4. And if those weren't the right numbers, then I would have just tried some other numbers. I'm just trying to get the V-shaped on here. So if I went ahead and tried that, then I had 0, 4, and then 1, 2, 2, 0, 3, 2, 4, 4. All right, and I'm going to extend that. That goes up 2 over 1. So I'm going to extend the left side, and then up 2 over 1 on the right side. All right, so that's pretty good. And where they intersect is right here and right here. And we just want the x values. So x equals 1, and the other one is x equals 2, 3, 4, 5. X equals 5. And those are our two solutions. And then to check our solution, remember how we do that? Is we just plug in 1. So like this one is absolute value of 2, which is 2. Over here we get 2 minus 4, which is -2. And the absolute value of -2 does equal 2, so that checks out. That's how you would check your solution, and then do it again with 5. Okay, so on this one, this is y equals absolute value of x plus 3, so that means it moves left 3. Other than that, it didn't have any changes, so that one I can graph without a table. I just move my vertex left 3, and then my sides are up 1 over 1, and then the other way up 1, left 1. All right, and I'm just going to draw that in real quick. And using a straight edge to get this in would probably be helpful. I don't know where they're going to intersect, so I went ahead and drew it, very largely. And then the right side, this has a horizontal stretch or a horizontal shrink inside. That's just really hard to do, so I just make a table. So I just pulled this up on a table, and I tried plugging in -2. I knew it had moved to the left 1, and so I was like, you know what, I'm going to go ahead and plug in numbers farther to the left because that +1 made it move left somewhat. Okay, so these were the numbers I got. I was trying to figure out where the y-intercept was, so I got -1/3, 0. Okay, so let's see if this works. So -2 up 1, 2, 3, 4, 5. All right, -1 up 2. Let's see here. 0 up 1, and 1, 4. And this is where I was kind of struggling because I didn't know where the vertex was, and that's why I did this point right here. I was trying to figure out where the vertex was. So that's -1/3, 0, so it's right there. And that just kind of helped me figure out my V shape better because I knew I had to have that bottom point somewhere. Okay, so it goes through right here. This is at x equals -1. And it goes through right here. This is at x equals 1. And because we see them going through on the graph, we don't have to check them for extraneous solutions. You can just check to make sure you're accurate and correct. And that's really all you have to do. Okay, so look at this one. You're studying 2 glaciers. In 2020, Glacier A had an area of about 40 square miles. So Glacier A had 40 square miles, and B had 32 square miles. Okay, Glacier A is melting. That means the area is going away at 2 square miles per decade. So I'm going to do -2x because it's melting. And Glacier B is melting at a rate of 0.25 square miles per decade. So once again, it's melting, so I subtract them. In what year will they be the same? The same means set it equal. Remember that X is the number of decades, because it said per decade is how fast it's melting. So what we want to know is when will they be equal? So we can set them equal to each other, and that personally would be my preferred way to solve. But since I'm going to go ahead and set them equal to each other, I'm just going to go ahead and graph them. So this side right here, I'm going to write negative 2x plus 40. And this side right here, I'm going to have negative 0.25x plus 32, or that's negative 1/4 x plus 32. Okay, so to go ahead and graph it, down here, I went by ones. 5, 6, 7, 8, 9, 10. I didn't know really how far we'd need. I had made a table first, and that's how I knew to go by ones. And remember, this is the number of decades. All right, and then over here, I knew I had a y-intercept of 40, so I went by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Make sure to write neatly enough that you can tell where your marks are. So 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. And so this is how big the decade is in terms of, or I'm sorry, how big the glacier is in terms of square miles. Okay, so Glacier A starts at 40 and then it goes down 2 decades. So remember that each box is 2 high and 1 wide. So I really am going down 2 over 1, but you're going to have to watch that when you do this, okay? Because you are going down 2 even though it's only 1 box. And the reason that is, I'm just going to draw this and fix it, is because the scale on the y-axis is going by 2s, but on the x-axis, it's going by 1s. And that's why that kind of seems odd. So if I follow it down, it's going to be right here. And that's pretty close. All right. And so then the other one I'm going to do is this right side right here. It starts at 32. Then it goes down 1 over 4. Keep in mind, that's the same as down 2 over 8. So if I go down a box, that's 2 units because I'm going by 2s, and then go over 8. So here is 5, 6, 7, 8. And then down a box, over 8. And that's what I'm going to draw my line as. So the reason why it looks like I'm going down 1 over 8 is because remember that each of the y-axis units are going by 2s. So you have to be careful with that. Okay. So I've got to figure out about where these intersect. See if I can get my line a little better. So they intersect right here. And that's kind of in the middle between box 4 and 5. So that's about 4.5. So what that means is that's about 4.5 decades. So if it was in 2020 plus 4.5 decades, which is each decade's 10 years, so 45 years. That means in about 2065, the icebergs, the glaciers are the same size, so about 2065.